used to store data. DNA has a lot of advantages when it comes to data storage. For example, it's ultra-compact and easy to replicate. A single gram of DNA can store up to 215 million gigabytes. The entire world's data could be stored in just 1 kilogram of the stuff. And you can store everything from text to images and videos in DNA. It can last hundreds of thousands of years and won't degrade over time like cassette tapes and CDs. In a recent breakthrough, Microsoft and researchers at the University of Washington developed the world's first DNA storage device that carries out the entire process automatically. Using the device, researchers encoded the word hello into DNA and converted it back to readable data. The device first converts the digital files into binary code consisting of ones and zeros, or bits. The system then uses specialized software to encode the bits into DNA sequences using strands of DNA's four-letter alphabet, A, T, C, and G. The device then synthesizes the DNA and stores it as a liquid. Next, the stored DNA is read by a DNA sequencer. Finally, the decoding software translates the sequences back into bits that can be understood by computers. This DNA storage device may be amazing, but the concept is not brand new. Scientists have been storing digital data in DNA since 2012. They encoded a 52,000-word book in thousands of small pieces of DNA, but the method they used was inefficient, and the storage capacity was very limited. Per gram of DNA, they could only store about 1.3 petabytes of data. Even though techniques are improving, before DNA data storage can be used commercially, the time and cost of synthesizing DNA and decoding the information need to come down. It took a whopping 21 hours to write the 5-byte hello message and read it back out. The device alone costs roughly $10,000. Adding this to the cost of precursor materials to synthesize DNA makes the process uneconomical. But DNA technology and synthetic biology are moving at an unprecedented rate. It cost $2.7 billion in 15 years to sequence the first human genome. Today, all it takes is one day and less than $1,000 to sequence your entire genome. While magnetic tape has increased in storage density, it degrades over time and requires specific storage conditions. DNA, on the other hand, remains stable for millennia and is inherently compatible with life's genetic information system. This makes it a superior long-term storage solution. Researchers are developing DNA drives that can write and read DNA data. Early prototypes have shown promising results, and the goal is to create a system that can write at high speeds and store vast amounts of data. The future of DNA data storage lies in using semiconductor chips and enzymes for synthesis, making the process more efficient and sustainable. Semiconductor chips provide precise digital control over the synthesis reactions, enabling high-density and high-throughput production of DNA sequences. Enzymes, such as terminal deoxynucleotide transferase, catalyze the addition of nucleotides, operating under benign conditions that avoid the use of toxic chemicals. This combination enhances the scalability and environmental sustainability of DNA data storage, paving the way for practical, large-scale applications. The development of DNA storage technology will revolutionize data storage, making it more efficient and cost-effective. It will also enhance other fields, such as biotechnology, by providing abundant synthetic DNA for various applications. However, this technology also introduces new security concerns, merging IT and biological risks that must be vigilantly managed. The use of DNA as a storage medium raises the possibility of unauthorized access and data theft. Unlike traditional digital storage, where access can be controlled through software and hardware security measures, DNA data storage introduces the challenge of protecting physical biological material. Ensuring that DNA samples are securely stored and handled to prevent unauthorized access is crucial. This includes implementing stringent access controls, secure transport protocols, and physical security measures.